Hello, aspiring Java developers. Welcome to another exciting tutorial. Today, we are diving into a super important and fascinating topic, Java multithreading and concurrency. Have you ever wondered how your computer can do so many things at once, like playing music, browsing the internet, and downloading files, all without slowing down too much? Well, multithreading is a big part of that magic. In this 5-minute animated whiteboard session, we will demystify multithreading. You will learn what it is, why it is essential for building efficient and responsive applications, and how to create and manage your very own threads in Java. We will cover the core concepts, look at practical code examples, and even touch upon some common pitfalls and best practices. So, grab your virtual pen and paper, and let us get started on this exciting journey into concurrent programming. By the end of this tutorial, you will have a solid foundational understanding of how to make your Java programs perform multiple tasks simultaneously. Let us begin. Alright, let us start with the basics. What exactly is a thread in Java? Imagine your program as a single road. Normally, your Java code runs sequentially, one instruction after another, like a single car driving down that road. This is called single-threaded execution. Now, what if you could have multiple cars driving down different lanes on that same road, or even completely different roads, all at the same time? That is essentially what multithreading allows us to do. A thread is the smallest unit of processing that can be scheduled by an operating system. Java applications are inherently multithreaded, even if you do not explicitly create new threads, because the main method itself runs in a thread. For us to create our own threads, the most common way is by implementing the runnable interface. This interface has just one method, run, which contains the code that the new thread will execute. It is like telling a car what route to take. Here, we see a simple myRunnable class that implements runnable and overrides the run method to print a message. This run method defines the task our thread will perform. Now that we know how to define the work a thread will do using the runnable interface, let us see how to actually create and start a thread. Simply implementing runnable does not create a new thread of execution, it just defines a task. To create an actual thread, we instantiate the java.lang.thread class, passing our runnable object to its constructor. Once you have a thread object, you call its start method. This start method is crucial. It tells the Java virtual machine to create a new system thread and execute the run method of your runnable object in that new thread. It is important to note that you should never call the run method directly on your thread object, as that would simply execute the code in the current thread, defeating the purpose of multithreading. Calling start is like giving the car the green light to begin its journey on a separate lane. The start method handles all the low-level details of setting up the new thread, allowing your main program to continue its own execution concurrently. Fantastic! Now let us put it all together with a practical example. Here, we have our myRunnable class again, which simply prints a message multiple times. In our main method, we create two instances of myRunnable. Then, for each runnable, we create a new thread object and call its start method. What do you expect to see when you run this program? Will thread 1 finish all its messages before thread 2 starts? Not necessarily. Because these threads run concurrently, their outputs will likely be interleaved, meaning messages from thread 1 might appear, then messages from thread 2, then back to thread 1, and so on. The exact order is not guaranteed, and it can even change slightly with each run. This non-deterministic behavior is a fundamental aspect of multithreading and is something you must understand when designing concurrent applications. This simple example clearly demonstrates how multiple tasks can execute simultaneously, making your applications more responsive and efficient. While multithreading offers great power, it also introduces challenges. One of the most common mistakes and difficult issues beginners face is something called a race condition. Imagine multiple threads trying to update a shared resource, like a counter variable, at the exact same time. If thread A reads the value, then thread B reads the same value before thread A has a chance to write its updated value back. You can end up with incorrect results. This is a race condition. Threads are racing to access and modify a shared resource, leading to unpredictable outcomes. To prevent race conditions and ensure data integrity, we use synchronization mechanisms. The simplest way in Java is the synchronized keyword. When you mark a method or a block of code as synchronized, only one thread can execute that method or block at any given time. It acts like a lock, ensuring exclusive access to the critical section of your code. For example, if we have a method that modifies a shared counter, making it synchronized ensures that only one thread can increment it at a time, preventing data corruption. Always be mindful of shared resources in your multithreaded applications. Alright, we have covered a lot in just 5 minutes. Let us quickly recap the key takeaways from today's session on Java multithreading and concurrency. We learned that multithreading allows your Java programs to perform multiple tasks simultaneously, making them more responsive and efficient. We explored how to define tasks for threads by implementing the runnable interface and its run method. We then saw how to create actual threads using the thread class and, critically, how to start them using the start method, never run directly. We also discussed the importance of understanding non-deterministic output when threads run concurrently and introduced the concept of race conditions. Finally, we briefly touched upon the synchronized keyword as a fundamental tool to prevent race conditions and ensure data integrity in shared resources. Multithreading is a powerful concept that requires practice. I encourage you to experiment with the code examples we discussed. Keep coding, keep learning. If you found this tutorial helpful, please give it a thumbs up, share it with your friends, and do not forget to subscribe to our channel for more exciting Java programming content. Your support helps us create more valuable tutorials like this one. Thank you for watching, and happy coding!